Okay, we're told to use a truth table to establish the following equivalence. Not P and Q is logically equivalent to not P or not Q. So I have broken down these statements into smaller pieces so we can get the truth values to determine these truth values. And if these two truth values are both the same, then we have proven that they are logically equivalent. So since I have P and Q, I will have four choices. So the first one will be true, true, false, false. Okay, for my Q, I will have true, false, true, and false. Okay, for my not P will be the opposite of P, so it will be false. For this one, it will also be false. For this next one, it would be true. It's the opposite of false. And this last one will also be true. Okay, for my not Q, it would be the opposite of Q, so it'll be the first one will be false. The next one will be true. The third one would be false. And the last one would be true. So just the negation is just the opposite of P and Q. Okay, so now we have the values. We can do these statements now. So not P and Q. So with an and, both have to be true for the statement to be true. And then after that we will have to negate it. So P and Q, these two values right here, true and true, both are true, so the statement is true, but we'll have to negate it, so it would be the opposite of true, which is false. For the next one, we have P and Q. It'll be true and false, so that statement is false because both have to be true, but the opposite or the negation of false will be true. So this one will actually be true. For the next one, we have false and true. That is also false, but the negation of it will be true. So this will be true. And we have false and false. That will also be false, but the negation of it will be true. So this one is true. Okay, now the last statement right here, not P or not Q, we have a or. With or, only one true value has to be true to make the whole statement true. So for not P or not Q, so we have to look at these right here, these two statements right here. So not P or not Q, so we have false and false. So that is false. That is false because none of them are true. We have not P being at false and not P at true. That makes the statement true because one is true. So the statement is true. We have true and or false. Sorry, I said excuse me, I might have said and, but it's actually or. true or false. So since one of them is true, the value of this statement right here is true. And lastly, we have true and true, that at least one of them is true, so the statement is true. And if you see here that these values are the same, so we have proven using a truth table that not P and Q is logically equivalent to not P or not Q. And if this is actually De Morgan's law, and it is useful in, like, if you're doing proof sequences and other little things with the proofs, so it's helpful. So this is the end of the proof.